Alright, so we're gonna continue on with where we were yesterday. And like kind of re-look at both the reciprocal and the rational function. So most of y'all, all of y'all, I saw you this morning, you came in and you finished up. A couple of y'all asked me some questions, some of y'all didn't. So either you didn't ask me questions because you knew what to do, or you didn't ask me questions because you didn't know what to do and you asked somebody else, whichever is fine. But hopefully, like I said, I know a few of y'all had questions, so we'll kind of see where we're at. So we're going to look at the reciprocal function first because it's a little bit easier. So this was in the form f of x is equal to 1 over x. This is like a review of both types of graphs because you're taking a quiz, not tomorrow, but probably Thursday. So just kind of so you know, and both graphs are going to be on there. All right? Okay, so the reciprocal is pretty straightforward. It has the rule about that, and actually the rule for both of them, because they're fractions, is we can't have zeros in the denominator, right? So just as a reminder on this, x cannot be 0. We are not allowed to have that. So if I have a number in this function that forces x to be 0, that's what ends up giving me a vertical asymptote. Are we okay there? All right, so for the parent, the vertical asymptote is at 0. This is the parent function. And it also has a horizontal asymptote at 0. The reciprocal is going to have both. Everybody okay there? And when we're just talking about the parent function, I don't know if you remember or not, but this one, if I plug in 1 right here, I have 1 over 1, which is 1. If I plugged in -1, I would also have -1. Everything else is going to produce a fraction. Are we okay there? So what happens on your parent function is it ends up just looking like this right here. And this right here. Alright, so that's that one. So the reciprocal is pretty easy. Y'all were okay there, and I had your papers graded, and y'all did fine. Alright, so my vertical asymptote was at x was equal to 0. My horizontal asymptote was at y equals 0. We have to know which one is x and which one is y. And remember, our domain and our range are directly tied to these asymptotes. So if I have an asymptote at x equals 0, then in my domain, x cannot be 0 because it doesn't touch that line at all. Okay there? The same is true for my range. If my asymptote is at 0, then y is not allowed to be 0. Any questions on that at all, or we're okay? Everybody's good? Okay. All right, so then here we have a couple of, we'll go down here. This has to do with our transformation. So I had f of x is equal to a, which is a shrink or a stretch, over x minus h plus k. These are transformations. Y'all should be familiar with all of them. Remember, h is a horizontal translation. And if it is, and these, remember, it's because it's attached inside here. Technically, I would probably write it like that. A lot of times they don't put it in parentheses. I'm going to write it that way just as a reminder that we would set it equal to 0. H is going to go to the other side, so the sign's going to be the opposite. Is everybody okay there? So if H is positive, it's actually going to go to the left. If H is negative, it's actually going to go to the right. We write transformations all the time. You should be familiar with those. K is your vertical translation. We get to keep the sign as is. So if it's positive, it's going up. If it's negative, it's going down. Everybody okay there? Mm-hmm. If your A value has a negative out front, it is going to be a reflection across the x-axis. If A is greater than 1, it's going to be a vertical stretch. Make sure you say vertical. And if it's a fraction, then it would be a vertical shrink. So your vertical asymptote is gonna be x is equal to whatever the h value is, and your horizontal is y is gonna be equal to whatever your k value is. All this we did, so y'all should be comfortable. I talked to y'all a little bit about a horizontal shrink and stretch. I'm not gonna deal with that right now. Or an x-axis or a y-axis reflection. I did that when we did the notes, so I'm not gonna cover it again here. You're not gonna really see them right now anyway. All right, so if we take a look at this one right here.
Sorry, what that last part say? Why you put what?
Okay. All right, so right here, what are my two transformations? Because there are absolutely two.
To the left one.
To the left one and
So
BT down 5. So those two things just give me what information? Say it again. Matrix and y. Kind. It gives you what? It gives me my asymptote. So what's my horizontal asymptote?
Negative
Wait, no.
Go.
Negative
one. Oh,
5.
negative
Yeah,
5.
before, sorry, I should have asked the other first. Yeah. This is y is equal to -5. My vertical asymptote is x equals -1. Is everybody okay there? Like, that's what those two transformations give me, is they identify my asymptotes. That's why we write them. So I now have a vertical at -1, and I now have a horizontal at -5 down here. Nothing else changed. There's no shrink or stretch here at all. So that means this is still going to be one away right here, and this one is going to be one away from that corner right there. As soon as I put another number up here, that is going to change that. Is everybody okay with that? If there's no other number up there, then I can pretty much do that directly, and I don't even really need my calculator for that. Save my calculator for when I actually need it, because we don't need it for that. Everybody okay there? So what would I say about my domain? X is -1 and y is not -5. Everybody okay there? Alright, sounds pretty straightforward. Alright, what about here? What are my transformations? X to the left 3. Alright, what else? Nope. X-axis reflect. That's the first one.
Oh.
Alright, so there's that one. What else is happening here? What? To be stretched by 2. If it's in the numerator, it's going to be, if that number is in the numerator, it's a stretch. If there was a parentheses down here, or it was attached to that x, then it would be a shrink because it'd be in the denominator. But it's not. It's in the numerator, so it's a stretch. Does that make sense? A lot of times, if they write it as if they want it to be a shrink, they're going to pull it out to the front and write a 1/2 in front of that whole thing. Does that make sense? All right. So it is a stretch by 2. All right. So I'm going to go ahead and identify what is my vertical asymptote. X equals -3. What is my horizontal asymptote?
0.
Yeah, y is still 0 there. So I'm going to go ahead and do 1, 2, 3. I moved my whole graph over 3, so it moved that over. Okay, now this one, this point's not going to be here because of that 2. Does that make sense? And it was reflected. So what normally is in this axis is now going to be, or up here in this quadrant, it's going to be flipped over down here. And what was normally down here is going to be up there. So they're going to be across right here. Does that make sense to y'all? That that's what happens? All right, so I mean, y'all can graph that one. That'd be totally fine. Probably need to be able to get points that are nice. Although I know -1 is going to be, looks like, -2, what we need to, -1. Yeah?
This one.
Alright, -2 gives you what, -2, right? Alright, so those are the only ones I'm going to be able to get over there. Everything else is going to be a fraction. Those I keep kind of doing in my head. Alright, so then if I go over here, then that means, what do I have here? 5 and 1s,
Mm-hmm.
and then negative 4 and 2. Is
Yes, sir.
that right?
Yes, sir.
You can factor that one side and figure out the other side, because they are, I mean, it is symmetrical, it's just symmetrical across an angled line. Alright, y'all okay there? Nothing else is nice in the calculator. Alright, so how am I writing my domain?
X.
X not negative 3, y not 0. Alright, so that one should have been pretty straightforward for you. Y'all, I said all y'all on that assignment, like y'all did really well, unless you just did polar directions. But otherwise, like, y'all were fine. So these were the ones that are going to give you a little more issue. So we're going to look at that. This is what we did yesterday. Alright, so remember we're in the form f of x is equal to p of x over q of x, and q of x cannot be 0 for the same reason that on the other side, thank you. For the same reason on the other side, x couldn't be 0, right? Because that's going to give me an error in my denominator. What happens here with these is I end up with either an asymptote, like I did on the other side, or a whole. That's what we looked at yesterday. Are we okay there? Now again, I don't do things in the order that they do things, and because I think the other way, my way is easier. You do it really however you want to. I really don't care. You are going to have to show me how you get what you get, but I always find it easier to figure out the wholes first, because a whole supersedes an asymptote. Does that make sense? So if I look at that and I'm like, oh, okay, that's an asymptote, well, that may not necessarily be true. So if I eliminate the wholes first, then whatever is left in that denominator is going to dictate my asymptote. Does that make sense to y'all? Okay, so a whole, like, trumps that. All right, so I'm going to do this in this order, and I'm going to say wholes, we're doing it first. Are we okay there? Like, that's where I'm going first. All right, so a whole, remember, is just a break in the graph. All right, so what I'm going to do is I'm going to factor my stuff. All right, so I'm going to factor, and it's going to look something like, you know, x, whatever, plus or minus some number over x plus or minus, whatever your numbers are, whatever your factors are. Are we okay? We're factoring the numerator, we're factoring the denominator. Everybody good? So then, I'm going to cancel common factors. We have to be careful there. We've got to have the right signs. Are we all right with that? Okay, so what I'm going to do as I'm filling this out is I'm going to work this problem to help us with that. Are we okay there? All right, so if I look at this right here, I've got a factor, because that's really the first thing I have to do. First is factoring. So when I look at problem number 1, my denominator does not factor, but my numerator does. How does it factor?
X plus 3.
X plus 3 and x minus 3, and then I have over x plus 2. So in this problem, do I have any common factors? No. So if I don't have any common factors, that means I don't have any holes. Does that make sense? So here, I have none. Are we all right with that? Okay, so I'm going to come down here and I'm going to look at this one. I'm going to kind of do the same thing. I need to factor my numerator and my denominator here. All right, how does your numerator factor?
X plus 1 and X minus 5.
X plus 1 and x minus 5. All right, what about my denominator? How does it factor? X plus 1 and x minus 1. Everybody okay there? So my common factor here is x plus 1, right? All right. If I took x plus 1 and I set it equal to 0, then x would have what value?
Negative 1.
X would equal negative 1 for that part of the factor. Yes, everybody okay with that? So that means the x value of my whole is negative 1. Are we okay there? So to find the y value, so I'm going to kind of jump back over here. So I'm going to say cancel common factor, solve for x. Everybody understand what I mean by solve for x? We just did it, yes? Alright, then our next step over here is gonna be, then plug into whatever is left. So whatever is left in the equation, this is now gone, right? It's totally gone. So what I now have is x minus 5 over x minus 1. Are we okay there? This is my new equation, because the other part's gone. Yes? Are we okay? Alright, so I'm plugging into whatever is left. So I have negative 1 minus 5 over negative 1 minus 1. So negative 1 minus 5 is negative 6, and negative 1 minus 1 is negative 2, and negative 6 over negative 2 is positive 3. So the y value of my hole is positive 3. Are we okay there? Alright, so I'm going to go draw my hole in. So I'm at negative 1, positive 3. 1, 2, 3. And I like to make my hole like super obvious, because I want to be able to see it. Everybody okay there? Alright, so we got that. So that's step 1, find holes. This one didn't have one, this one we got figured out. Is everybody okay finding the hole? Alright, step 2, I go to the vertical asymptote next, because I already have it factored in. It's super obvious to me what's left. The vertical asymptote is going to be any factors on the bottom that are left. Does that make sense? Left. And I need to solve them, meaning set it equal to 0. Are we okay there? So I'm going to go back up to my top problem. My only factor in the bottom is x plus 2, right? If I solve that, then x would be equal to negative 2, right? Yes? So my vertical asymptote here is x equals negative 2. Are we good? I'm going to draw that in. Now it's kind of weird what two problems at the same time, but we're going to do it. Y'all okay there? Alright, if I go down here to this one, my factor that was left in the bottom was x minus 1, right? Which means x has to be positive 1. Yes? Alright, so x is positive 1. So I'm going to go write my vertical asymptote right here. X is equal to 1. And then I'm going to go draw my asymptote in there. Everybody okay there? All good? Okay. Then the next place I'm going to go is my horizontal asymptote. Alright, so if, and we're talking about the degree. What do they mean there when we say the degree? What's that talking about? Yeah, the exponent. Alright, that's what we're looking at. So we're looking at the exponent. Alright. That's where I'm looking. Alright, so I'm looking at the exponent. Alright, if P is greater than Q, then there is not going to be a horizontal asymptote at all. Are we okay there? I will give you these, because I know y'all won't remember them, so I'll give them to you when you take your quiz. Alright, if P is less than Q, it's going to be y equals 0. Alright, and if P is equal to Q, then I'm going to do leading coefficient over the leading coefficient. And then I'm going to get whatever that number is. So, are we okay there? Any question on that, or we're okay? We're everybody's clear on that? Alright, again, for your quiz, I will give you those. I'll give you these 3, because they're kind of hard to remember. You usually figure it out from your graph, but I'll give it to you. Right? Okay, so now I'm going to go back over here to my problem. I'm looking at this. So I'm looking at, because this is my VA, right there, it's my vertical. Alright, so for my horizontal asymptote up here, I'm looking at my degree. So I have P and I have Q. What's the relationship between P and Q? Yeah, P is greater. So what does that mean for my horizontal? It means there is none, right? So I don't have to worry about it. So when I get over here at horizontal asymptote, there is none. I don't have to worry about it. Are we okay there? So we'll come down to this one, this was my vertical asymptote. Alright, so now look at my horizontal asymptote. What is P and the relationship to Q? Huh? They're equal. What is my rule if they're equal? Yeah, leading coefficient over leading coefficient. The leading coefficient here is 1. The leading coefficient here is 1. 1 divided by 1 is still 1, right? So it's at y is equal to 1. Go draw it in. You're okay there? Questions or we're good? Okay, got it. Alright, last thing is your x-intercept. So this is your fourth step. Okay, any factors left in the top solve. We're setting them equal to 0, we're going to solve. If it's just a whole number up there, you're going to have to worry about it, right? If I'm just left with a 1 or everything cancels, then I don't have one, then it's like a reciprocal function, which means if I'm not going to have one, that means I have an asymptote at y equals 0. Does that make sense? If I have an asymptote of y is equal to 0, I will not have an x-intercept. Is that logical? Okay. Alright, so here, come over to this one. I have 2 factors left, right? Are we in agreement there? This one is going to be equal to what? -3. This one is going to be equal to what? Equals +3. So I have 2 x-intercepts. -3, 0. +3, 0. Alright, so +3 and 0. -3 and 0. This one is going to look a little bit crazy when we graph it. We'll go graph them in a minute. Are y'all okay there? Mm-hmm. Alright, so we got that. And I can go ahead and write my domain and range here. What's my domain going to be? X cannot equal -2. What do you think your range is going to be? Huh? It's going to be all real, so there's nothing restricting it. Like I said, this one's going to look a little bit strange, but we'll get it in just a second. Are we okay? Alright, we'll go graph it in a minute. Alright, so let's take a look at this one. What about my x-intercepts here? Yeah, this one's going to become +5, right? So I only have 1. 5 and 0 out here. Alright. So I can go ahead and write my domain and range here. What's my domain going to be? Yeah, it can't be -1 or 1. And y'all could write ± 1. I don't care how you want to write that. Alright, what about my range? Yeah, 1 or 3. Y'all okay there? Remember on these, any holes, any asymptotes are restricting your domain and range. We good? Okay, so now let's go graph this one up here. So, did I? Oh, it should be 3. Sorry. Thank you. Sorry, thank you. Alright. So let's go graph this one. It looks very different than what you've seen before. You'll see some of these later. Some more. So it looks a little bit different than what you've seen. So let's get some points over here. What do we got on the negative side? Anything at all?
-1 and -8.
-1, -8, okay, right here. What is it at 0?
-9/2.
Huh?
-9/2.
Okay, so -1. There. What is it at 1? Yeah, sorry, +1. I'll go ahead and get the positive side over here. Anything at 1 or 2 that we could use? No. Alright, what about out here to the right? Is there anything over here that we can use at all between 3 and 10? I get another point. Alright, find me something that is a halfway decent fraction that I can figure out what it is. Anything over 2? -5 over 4?
Oh, there's -9 over 2. -9 over 2.
-9 over 2. At what number? I already got that one. I need something out here, like somewhere over here, cause I need to see where this graph goes.
11
11 over 2, okay, that's 5
at 8.
at 8, okay. 1, 2, 3, 4, 5 and a half. Like, you gotta get something out there so you can see where this is going. Alright, so it does this, alright, that helps me out. Alright, so now let's go back over here. Now let's find something on this side that we can use. I know we're not gonna be able to find anything here that's gonna be approaching this asymptote, so I need something out here somewhere.
-4, -7 over 2.
-4 and -7 over 2, which is -3 now. 1, 2, 3 now. Alright, right there. Alright, anything else out here?
-7 and -8.
Negative what?
-7 and -8.
-7 and -8, that's perfect. Good enough. That's what I need. There we go. Alright, so it's something like that. Which you should be able to tell, like, if you turn this at an angle, you see, this should be somewhat symmetric. It's sometimes a little bit difficult to see, but at an angle, like, you should be able to kind of tell that. You'll see what I'm saying? Alright. The last one down here. Okay, so y'all graph that one for me. Probably not a ton of points that we can use.
-3 and
-3 falls to 2, and 0 is gonna be what, 5, right? That's probably also gonna use, alright, switch screen. Okay, got that one. Alright, and then over here,
2 and
2 and what?
-3.
3, alright. Anything in between those 2 points?
0.
3 and what?
3 and -1.
That works. Alright, so it's something like that. Okay, y'all have any questions? Kennedy, does that help you a little bit? Are here yesterday?